Hello, everybody, and welcome to another episode of Analytics Mindset. In this episode, we will start with database basics by starting with SQL. In contrast with most of my other videos, this is going to be assuming that you have almost zero knowledge of SQL. If you feel familiar with SQL, feel free to skip this and see other videos I will put in the future going more into detail about the exciting world of databases and how you can be more proficient on it. In the meantime, we will start with the very bare bones basics of SQL. The theory behind relational databases is outside the scope of this video. I will leave resources in the description if you're more interested in that. However, this video will be fully focusing on the practical implications of it. Maybe you are in a job position that you need to retrieve some data from databases, or you just want to learn a new way of extracting data. This video is for you. Again, if you are more curious about the theory behind it, both SQL and relational databases, I will leave it in the description. However, with that, we can get started. SQL stands by Structured Query Language, and I personally do not consider it a fully programming language, though there is quite a bit of people that do. For me, it's more of a scripting language. Think it of as the way you communicate with a database, how you tell a database that you need data, and then the database will know how to send it back to you. The query below, this query over here that I'm highlighting, is going to create a table that we will be using during this exercise. A comprehensive understanding of how to create tables in SQL Server is outside the scope of this video. I will not go through it. I will also not go through how to set up your database. However, I will leave instructions in the description as well for that. What you need to know for now is that once you have installed Microsoft SQL Server Management Studio, or alternatively, you could use MySQL, you can just create a table here in this database. In this case, I have my database here that you can see my Object Explorer called Test Database. I'm going to create a new table called Houses. This table Houses is going to have the following columns: street, that is the address of the house; state, that is the US state where the house is; the price, that is how much and what is the house; the price date, that is what this price was assessed; and the years since construction, how much time has passed since this house was actually built. You will notice that I'm using SQL Server Management Studio. This is an interface that Microsoft provides for SQL Server. There are multiple variants and also equivalencies in other relational database management system providers, but I do prefer this one. This is your script. This is the actual SQL code here, and this is your Object Explorer. To start with this, I'm going to take this part of the code, the create table. Notice how I'm including the semicolon because it breaks the code here. And I'm going to press execute. As you can see here, a pop-up window with results will come in and say commands completed successfully. So what does this mean? This means that I have created a table. And actually, if I come here and then I go into tables, it is not there because it's not refreshed. I'm going to refresh this and go here. You can see that my houses table is there. However, I just have created an empty table. There is nothing there. If I try to query this, that actually we can just do it on the fly. So we're going to do it here, select everything. This is what means everything in SQL. You're going to get very familiar with that. And I have the address of this house here, but I can just get it from here. And I press execute. It's empty. There is a table. It exists now, but it is fully empty. For that, we need to actually insert stuff into this table. So we're going to do it with this query here. Again, remember, don't worry that much about the syntax because this is a more advanced stuff. In 99% of the cases, you will get a table with a lot of data already. I'm just doing this to have an example to show you. Unless you are going straight into a DBA role that stands for a database administrator or a more advanced role managing databases, I do not expect you to need to know this pattern match, they insert into values, etc. But as you can see here, it's very straightforward. You just declare your columns here, and you insert your values that need to match the data types here. For example, price needs to be an integer, so it needs to be a number, and state and string need to be partial, so they need to be text. I'm going to take all of this and execute it. As you can see here, it tells me now something different. It says 10 rows affected. This means that now, when I'm going to take this again and execute it, I'm going to get stuff. Why? Because this is in the database. This is the most basic SQL query that you can ever have, and you're probably familiar with this and have seen it before, because this is basically the first thing that they teach you when they teach you SQL. It says, select all the columns from this table. That is all. That's all I'm doing here. I'm saying, you see this table that I provided to you? Give me everything back. If you want to think on Excel terms, I just said SQL, give me the whole spreadsheet back. Whatever you have, give it back to me. That is what the select star from this makes it returns here. Now, the power of SQL does not rely on, oh, I can access these databases now and I can create data pipelines to manipulate somewhere else. The main power of SQL is how adaptable these queries are. You have a whole language that you can put parameters, select columns, filter cases, do subqueries, do CTEs. Your opportunities are basically endless with this language. You can do so much more that you could do if you downloaded this as an Excel file and a CSV, a create a report in a pivot table, as I will give you a very high-level overview of it. But for now, just know that SQL allows you to write your logic into the query and then call it a day. And if you need to do it again, you don't need to do each step that you will do in Microsoft Excel, for example, or other tools that you will basically drag and drop stuff all the time, but just execute it again and it will remember each of your steps. This is going to be very important later on. Now, as you can see here, it returns me 10 records as the 10 records are inserted in this table, but I don't want all the columns all the time. I can limit my query. This is very important too, more so if you are working with big tables. This is just 10 records, but your table might be 10,000 records, 1 million records. I've worked with tables that have more than 100 million records, and that takes a very long time to run. It is very bad practice to use select star from everything. You should avoid it unless you know your data is small, or unless you know what you're looking for, or you want to limit it with commands like limit and top, depending on what tool you're using. However, in this case, we're going to use just some columns of this. So we are not getting the whole table. We just want the price of the house and the year since construction. We're going to replace our star here, and we are going to actually name the columns here. So what this is going to cause, if I take this, highlight it, and execute it, is I'm going to have the price here and how many years have passed since construction. Now, as you can see here, SQL is just selecting these columns here. It's not doing anything else. It's just saying, you want 2 columns, I'm going to give 2 columns instead. Now, we have our 10 houses again, but with these prices and years of construction. However, as I told you before, the biggest advantage of SQL is that it allows us to write a script that we can reuse later. But in this case, for example, we're going to use the where clause. The where clause is basically a filter that allows you to do very elaborating stuff that I will not go into right now. But here, for example, for the same query that we did before, I'm saying, give me the price and the year since construction from this table where and only where the year since construction is less than 10. If I run this, I'm getting 5 records because, as you can see here, these 5 houses are the only ones that are less than 10 years old. And again, you probably could do this in Excel if you wanted to just put into the column and filter that out. However, SQL allows you to already have that here. And because you can connect to databases in a lot of platforms, even Excel itself, you can connect to databases and do a SQL query. It gives you a ton of flexibility on communicating reports or creating automated reports. The magic of automation with databases is that it allows you to do so much more if you understand what is under the hood here. Aggregations are a pretty important part on SQL that in Excel you most likely will use a pivot table for this. But let's say I want to count all the houses. Now, this table does not have a field with an ID that I can say like house ID. However, I would just assume that for each row, there is one house and only one house, and that each row cannot be repeated. So each row will be a house, and I will assume that a house cannot be repeated. That is table specific, and that's where it comes a lot on the modeling side of it, but it works for this specific case. So I'm saying count me everything, the rows, from this database table. As you can see here, there's 10 houses here. Now we can go further than this, and I can create a flag. I'm going to create a Boolean flag, basically saying yes and no, and saying if the house is less than a decade old or more than a decade old. And I'm going to use the case when syntax for this. I'm basically saying select all case when years since construction is less than 10, then yes, else no, and end as new house from this table. Now, here you can see something very interesting here. The logic is wrong. This is not a new house. This is an old house. It's 18 years old. And this is a new house, but it's flagged as no. The reason why this happens is because SQL will take whatever condition you have here and then compare it and then say, this is the Boolean flag, yes and no. So in this case, what I want to do, what the simplest way to troubleshoot this is just flip the sign. And then I run it again. As you can see now, this flag is now correct, classifying all the new and the old houses in their bucket that they should. The moral of this is you always want to check the logic of your query, especially with these fields that you are creating and are not in the database. You have no way of verifying if those fields are correct besides whoever created them. So if you get a query from somebody and has a field like this in a case when statement, you will always want to verify with them beforehand. Now, we can even use this derived field to do a lot of stuff, but here you can see an example of the power of SQL. I'm basically saying what you did before, all of this stuff here, you are going to return me this query. This is a query by itself, but it's a subquery inside another query. I'm basically saying count me the street addresses and also by the new house flag and group by the new house flag. So what this is going to look like is like this. It's going to have 5 houses here and 5 houses here. And now you're going to notice that here I have no column name, even though it has street here as a count. That is because SQL, by default, when you give an aggregation, it creates a new column, even if it has the values of another column. I do want to give it a value though, because I do not want to be empty. I will just call it with as. That is what is going to assign a name to this column. And I will just put number of houses. Now, if I execute this again, now I have my label here. If you want to go back, go back. This is a more advanced level of SQL where you're basically creating a subtable here and doing the right field here to then count or aggregate by that field. It is very powerful, and this also goes to CTEs, where you can do the same thing as here with a different and more simplified syntax that is easier to follow. However, I do recommend you to be more familiar with how to do a query first before jumping to subqueries, because the logic can be pretty messy, and if you go into subquery to subquery to subquery, you might get lost on it. Now, the last thing we're going to do is just drop the table. We may want to just clean it up because it might be too expensive. We have done changes. We have not done changes in this case, besides cleaning the table and adding stuff into it. But I will just go ahead and drop this table. Now, if I want to try and do any of my queries before, I'm going to get an error because the table does not exist. The table has been deleted. Therefore, there is nothing there. And with that, I hope that this showed you a little bit of the capability of SQL. If you want to learn more about it, again, I'm leaving a lot of documentation and resources in my description, and I will for sure follow up this video with some other videos, going more in detail with each of the statements here. What is the select clause? What is the from clause? What can you do with where? What can you do with group by, etc. But with that, I hope you found this useful. And if you like this video, please give me a like, comment, subscribe. I appreciate any feedback that you can give me. And with that being said, thank you. Take care.